So let's say we are to take the divergence of the following vector field. The divergence of AU plus BV, where A and B are constant scalars. Then it turns out that this can be equivalently expressed as A times the divergence of U plus B times the divergence of V. Right? And we can prove this. And so that's what we're going to do. We're going to prove it. So, proof. Let's start by just writing the left side of the equation right here. Well, if you recall, the del operator is just like that, right? And we're dotting it with this entire thing. Now, notice how we have the I component, j component, and k component. Well, that's exactly what we're going to do with this vector. We're going to think about the I component, the j component, and the k component. Well, the I component will look something like this. It would be AUX plus BVX. So this would be the I component. Hopefully we can all agree with that. As for the j component, it's going to be exactly what we have here, but instead with uy and vy, right? So that would be the j component. And in the same exact way for the k component, it's going to be AUZ plus BVZ. And so that's exactly what it is. So we're basically taking the divergence of this vector. So now it looks pretty easy into how we're going to take the divergence of this thing. It's going to be the partial derivative with respect to x of this thing, plus the partial derivative with respect to y of this thing, plus the partial derivative with respect to z of this thing. Right? That's exactly what it means to take the divergence of this in component form. So I'm just going to write that out. Partial derivative with respect to x of this thing, plus the partial derivative with respect to y of this thing, plus the partial derivative with respect to z of this thing. So now at this point, it's just basic derivatives. I like that. That was good. So it's just basic derivatives. Now you can imagine that we can re-express this as a partial ux with respect to x plus b partial vx with respect to x. And basically that's what this would be. In the same exact way for the other ones, we get that. Now at this point, I want you to realize something. I like that word, realize something. It's like you don't know something yet, but you do. No, but this is actually, should be pretty easy to see. You can see all of the terms that have A in it and all of the terms that have B in it. But really, focusing on the terms with A in it, we can factor out A. And so if you factor out A from the terms in red, you get this. And if you factor the terms with B in it, you're going to get this. And that's basically the idea. But this is the divergence of vector u. This is the divergence of vector v. So this is basically it. We're basically there. This is the divergence of vector u. This is b times the divergence of vector v. And so we have shown that this is equivalent to this. And so that's basically how we would do this, right? And so this is basically it for this video.